Howdy and welcome back. So we're going to talk about different ways to traverse our tree, that is to visit each of the nodes. And we'll see here that kind of the difference between an in-order, pre-order, and post-order traversal is going to be the order in which we're going to process the nodes. So an in-order traversal, we're going to process the root of a subtree between processing the values in its left subtree and those in its right tree. If we look at the ordering enforced by the binary search trees property, an in-order traversal would essentially print, if we were to use an in-order traversal to print the nodes, it would print the nodes in order by their key in ascending order. So in this case, it would be 4, 8, 10, 12, 14, 20, 22 is the order in which these would be processed. So to break down the code for this traversal, what we're going to essentially have is, and I'm just using a blanket node with a single type T. Again, the definition of this function and in-order tree walk would be dependent on the composition of the node that we're using to implement this data structure. So if the node's not equal to null pointer, we're going to go ahead and walk left. And then when we return, it's a recursive call. When we return from the left walk, we go ahead and process the current node, and then we'd continue on and walk the right tree, doing the same. Let's go ahead and see what this kind of means in practice. So what we're going to see here in the diagram on the right is the red is going to signify that we've essentially came into a recursive call of our in-order tree walk. A green colored node is going to imply that we've hit the process node portion. So let's go ahead and kind of step through this. So for an in-order tree walk, we're going to begin at the root. So we've gone ahead and launched up. In this case, on the stack, we'd have an activation record for in-order tree walk. And let's just go ahead and call it 20. Okay, so what's the first thing we do here? We check if we're at the base condition. We're not. So we're going to go ahead and call in-order tree walk on the left node. So here we'll go ahead and fire up in-order tree walk on 8. Let me just go ahead and copy this, and I'll kind of walk through this. So we're now at 8. We've just entered the in-order tree walk function call for it. So the first thing we're going to do, check if the node's the null pointer. If it's not, we're going to go ahead, if the node's storing the null pointer. If not, continue on. So in this case, we're making another recursive call. In that case, it's going to be to the node 4. Okay, so let's go ahead and visit 4. Now notice here, in both cases, the left and right point to the null pointer. So we would make a recursive call with the null pointer. And effectively, we're not going to get into the body of this conditional, so nothing's going to happen. And yeah, we could have, maybe structured this conditional better, so we'd push an activation record to the stack for the null pointer, which is effectively useless at this point, but just illustrating this. Okay, so we then return from that function. So I'll copy this, go ahead and put it over here. And at this point, we've returned from that, and we're back where we left off in the execution of in-order traversal for node 4. So we've already stepped left, and at this point, we're processing the node. So I'm showing it in green. After we've processed that node, and this could have been just printing it out to standard output, doing whatever sort of thing you would have liked to have done with it. Then after doing that, we'll go ahead and call in-order tree walk. Was I calling it in-order traversal? Well, in-order tree, whatever the name of the function is, it's now called on null pointer again. Why? Because to the right of this node, its right pointer is pointing to nothing. So we go ahead and get into that nothing would happen. So we'd return from it, and the activation record for that would be popped off, as well as for 4. So both of these activation records are popped off. We're done in 4. And guess where we are? Back in 8. So we've already stepped left. We've already visited the left subtree of the node with the key value of 8. And now we're at that node and we're going to process it. So if we were printing out, say, the values, if all this process node comment was a C out to standard output, so far we would have observed 4 and 8. So kind of it's paying homage to its name, right? It's visiting the nodes and processing them in order. So after we've visited the left subtree, we've now processed the root. So we're processing the root now in between the left and right subtree. So guess what we're firing off next? Inorder tree walk on 12. So that's going to be pushed to the stack. And guess where we are now? We are not at the null pointer. So within our execution of inorder tree walk for the node with the key value of 12, first thing we're going to do is make a recursive call to the node on its left, in this case, 10. So I'll go ahead and write that out in order tree walk, the node of 10. And again, notice I'm just passing an integer value here to kind of show you the keys in terms of what functions being invoked. So follow along with that, hopefully. Okay, so now we're going to go ahead and visit the node with 10. So let me copy that and continue on this walk. Okay, so what's the first thing we're going to do here? We're not at the null pointer, so we're in here. We need to walk to the left. And that's going to be the null pointer. So nothing's going to happen. Now we're going to arrive back because the activation record for that function invocation is going to be removed from the stack. We've just done that. Now we're going to process the node. So if we were just, again, writing out the node key values to standard output, we'd have 4, 8, 10 so far. Pretty cool, eh? Okay, now we're going to go ahead and check right. So in this case, in order tree walk, null pointer, and we'll see there's no work to be done there, right? So we're going to return from that function invocation, and then we'll go ahead and return from the invocation on node 10, and guess where we're going to be? We're going to pick up where we left off in the function invocation of inorder tree walk for node 12. So at this point, we've gone left. We're now processing 12. So again, if we were printing these values out, 4, 8, 10, 12 so far in order, as one might suspect. And then we have to make our recursive call to the right. So in order tree walk 14. If you kind of see the picture here, I'm just going to keep going through this. So, feel free to speed it up if, this is clicking. So let's go ahead and check that out. We're going to visit 14. So here we are at 14. We're going to begin processing by first, because it's not the null pointer, walking left. So in order tree walk, and this will be the null pointer. Let's go ahead and visit it. We'll come back after that activation record is removed from the stack. We're back where we left off in 14. We've gone left. We're now processing that node. So far, we were printing to standard output. We'd see 4, 8, 10, 12, 14. Cool. Now we have to step right. In this case, it's invoking the function on null pointer. All righty, let's go ahead and visit that. Nothing's going to happen. We'll return back to our invocation of inorder tree walk for the node whose key value is 14. At that point, we're done. With that, so we go ahead and return to the caller. So at this point, look what's getting popped. That activation record, and guess where we are. Oops, we've also popped 12 because we've gone right of 12. We've already visited, so let me just mark here, we visited that node, that node, that node, that node, that node. So actually all of these activation records are popped and we're back at the root. So now we're going to process the root, right? So we've gone left for the root. We're now processing the root. So in this case, if we're just printing everything, we've seen 4, 8, 10, 12, 14, 20. Notice everything's in order so far. After we've processed the root, guess which way we're going? In order, tree walk to that node, so of 22. So first thing we're going to do, I guess I missed one little red node here, but okay, we visited 22. I'll try and remember to go ahead and put this back in the slides that get uploaded. But we'd go ahead and go to 22's left, which would be the null pointer. Okay, let's go ahead and return from that. We'd process the node. So 22. So at this point, we'd have 4, 8, 10, 12, 14, 20, 22. Last thing to do, step to the right of 22. It's going to be null pointer. So we step there and then we begin returning. We've already gone to the right of 22, which means we're done with 22. And guess what? We've already gone to the right of 20 and we're done. We visited the nodes and processed them in order. So now we'll go ahead and get into a pre-order traversal, post-order traversal, and then we'll go ahead and get into finding the minimum and maximum value within a binary search tree, searching for a particular value, and then this idea of a successor.